we are going to start out with one problem from Stoichiometry 3. First, I'd like to go over some of the upcoming things. Today, Stoichiometry 3 is due. Obviously, if you were gone on Monday and you didn't get it, you're going to have extra day to do that. We are going to have a mini quiz today. We told you this last week, told you at Monday, so shouldn't be surprised you guys. That's what we're going to go over one problem before the mini quiz starts. It's basically on limiting reactants, so the stuff that you learned last week. It's going to be a good gauge for you guys to find out where you're at heading into Friday, because our stoichiometry test is Friday. So you're going to get a review today that's going to be due Friday, the rocket lab's due Friday, and your test is Friday. Alright, tomorrow we're going to be doing mostly a review day as well. The only other thing I'd like to point out right now is that the last day of the quarter is next Thursday. That's March 24th, I believe. So any makeup labs, late work, any of those things need to be done by then. Okay, that's pretty much with no exceptions asked on that. Alright, so you have next, basically Tuesday and Thursday are good days for us to come in and get that stuff taken care of. If you have a time besides those days that you need to meet with one of us, then you have to come see us and let us know. If you go and wait till Thursday, and after Thursday after school you go, Mr. Newbar, but I didn't have times that match yours. Well, you waited too long and you're out of luck. Okay, so you need to be proactive about this and come talk to us right away. All right.
Can I also add that we do appreciate you coming to make up your labs, but we really do appreciate when you talk to us a couple hours or a day ahead of time, rather than showing up and saying, I have a lab to make up. So, not that that could never work, but
especially when it's a lab that we haven't done for a while. Because like we have a rocket lab still set up right now. But if you're trying to make up a different lab, you guys, chances are we put a lot of that stuff away already. So if you just come in on the spot and ask us, hey, can we make this lab up? Well, that means like we got to go in the back and dig all that stuff out for you. Okay, so we appreciate you coming ahead of time. Guys, every single time one of you whispers to somebody else next to you, it's just a lot. Okay, so I would appreciate it if you'd be quiet, please. Thank you. The question here from Stoic 3, we're going to work on number 5. Okay, number 5 is probably the most challenging type of problem that you guys could see on the test on Friday as well. So if you could do this one, you're going to be sitting pretty well for that test. It says, what is the actual yield of H2O when 23.4 grams of oxygen reacts with 9.75 grams of hydrogen when only 58.5% of H2O is produced? There's a lot of stuff going on here. There's percent yield stuff going on here, and there's a limiting reactant happening here. So first thing we need to do is we got to have the balanced equation. Okay? Our balanced equation is 2H2, this is the same reaction that we did in the rocket lab, plus O2 is going to yield 2H2O. Okay? Now, we got to use our information here. It says, what's the actual yield of H2O? So, what I want to know is grams of H2O. When 23.4 grams of oxygen. So down here I'm going to write 23.4 grams. Reacts with 9.75 grams of hydrogen. So by the hydrogen I'm going to write 9.75 grams. Anytime that I see two values like this, it means I'm doing a limiting reactant problem. Okay? I have to figure out which one makes the less of that product. Alright, so that's what we're going to start with this one. So I'm just going to start with the O2, and I'm going to write 23.4 grams of O2 to start. Alright, and that's going to be the top left of my T-chart. To get from grams to moles of O2, I need to divide by molar mass. So I'm going to write grams O2 down here and moles O2 on top. Now I need to figure out how many grams are in that 1 mole of O2. Look at the periodic table. It's 16 grams in 1 O2, so this should be 32 grams, and that's in 1 mole of oxygen. All right, now this next step, I'm going to have to use the mole ratios. Now that's our numbers up here. Okay, so I'm going to write mole O2 on bottom, and I'm trying to get to moles of H2O at this point. Okay, and the ratio is 1 to 2. This is not 0 here. Okay, this is 1 when you see it by itself. Now, this part here in the very last step of the T-chart That's going to be the same for our oxygen T-chart and our hydrogen T-chart. That's why we say it's a problem and a half. So I'm only doing this figuring one time. Now, moles H2O has to go down here. And then I have grams H2O on top. That's what I'm trying to get to. And so, in 1 mole of H2O, there's 18 grams. It's important, like I said, when I do the next T-chart, this part here is just going to go right into it. I don't need to do that work again. So then it's just plug and chug in my calculator and figuring out what that one should be. And for this, you get 21.3 grams of H2O. Well, we're not done yet. We need to figure out how much the hydrogen gas could make. So we're going to start out at 9.75 grams H2. All right. Now, grams H2 goes down here, and we can kind of use the one above for a guide. Now, we're doing the same thing here, guys, just that we're using grams of H2 instead of grams of O2. Okay, so down here we're going to have 2 grams of H2 in 1 mole H2. For the next step, it's mole ratio again. So we're going to put moles H2 on the bottom and moles H2O on top. This is where the problem is the same now, okay? We're going to put 2 moles H2 here. That's the last spot where it's different. And then we look up there, okay, we have 2 moles of H2O there. Now we look here, it was 1 mole H2O, and there was 18 grams of H2O in it. So we're not doing that work twice. It's like a problem and a half. All right, and the answer that we get is, sorry, where am I at right now? 26.3, or sorry, 87.75. My bad. 87.75. Oh, and I write like a child, so this is actually 26.3. I'm sorry, you guys. I don't know how many ones the Big Six is, well, whatever they did, so I'm over it. Okay, so our limiting reactant in this case is which one? O2. Right, O2, the one that makes less H2O is our limiting reactant. Now, we need to use this to find the actual yield here. So when you look at your percent yield equation, you have actual over theoretical, and that equals your, well, times 100 equals your percentage, okay? I'm just taking that times 100 right now. Now, what we want to solve for is this actual. So we're going to solve the equation for actual, so we're going to have our percentage times our theoretical, and that's going to equal our actual yield here. So this is what our theoretical yield is. It's at 26.3 grams. So we're going to plug in 26.3 grams H2O times our percentage expressed as a decimal. What's 58.5% expressed as a decimal? 0.585, right? So we're going to multiply by 0.585. That's going to give us what our actual yield was. So what our lab result was, and that should be 15.4 grams of H2O. So that's our final answer there. Okay? This is what our answer was, our theoretical answer was, but this is our actual yield. Okay? Does anybody have questions on that one? Perfect. Clear everything off your desk. You might want a periodic table right now. If you want to use your lab notebook one, that would be fine. You're going to need a periodic table. If you can see the one up front, that's fine. But for those in the back, I want a periodic table. So you might need a periodic table, calculator. Everything else needs to get put away. Worksheets, folders, I don't care what it is. Put it away. No.
I don't know. Chair. We can't.
No. Calculator up front. Okay.
Yeah, well, you're up there with this thing, Justin. What? You're supposed to see all.
Yeah. Ready? All right, if you need to use your own periodic table, make sure that it is clean. If it's in your lab notebook, you're not going to be flipping pages. Just put your periodic table in front of you, not between you and your partner, you and your neighbor.
When you are finished, please come put it up in the corresponding bin up here. And then you can grab one of the review half sheets that's up here. That's something you were trying to grab when you came in today. Okay? Alright. It needs to be silent in here now. Over last notes and quizzes already, guys. It's got to be silent until the last quiz is in. remain quiet until after the question. Thank you. You want to start working on the sheet that you just got, try number 4, that one might be just the other up on the board. We're going to do the other first 3 together in a minute.
All right.
We work on 4, like I said, quietly while everybody finishes off. Don't complain if you fail a test.
Can I do number one?
Is there any more mini quizzes out right now?
No.
Okay. You're just going to need that sheet out in front of you. We're going to go through a few things that are together right now. Hopefully, great for the test on Friday. The first thing that I'd like to go over just one more time, I know most of you know this by heart now, and that's good. You have 6 circles on top of your sheet, guys, because obviously there's particles and grams over here. But if I were you guys when I got my test tomorrow, I would write this on the top of the test. Like, this is not going to be given to you in the test, but you're free to write whatever, anything that you want on there. So this is something that I would do if I were you guys as soon as I got my test tomorrow. It's kind of like a roadmap that takes you through stoichiometry. Like, if you get stuck on a problem, this is something that you can reference back to help you figure out how to get through these problems. The things that you need to fill in right now, obviously you need to put moles, grams, particles, and moles in there. But I just want to point out, if we're going from moles to grams or grams to moles,
Friday.
did I say tomorrow again?
Twice, 3 times.
I said it last month. Yeah. It's Friday. I misspoke. We always do reviews the day before. I don't know. Yeah. So on Friday, when you're going from grams to moles, you got to use the molar mass. If you're going from moles to grams, you multiply. If you're going from grams to moles, you divide. I think most of us are comfortable with this, but once again, it's just kind of nice to have something to fall back on. When you go from moles to particles, you use Avogadro's number. That's 6.022 times 10 to the 23rd. Now that's the same for any molecules that you might have. Doesn't matter. The thing that could be different is that molar mass, but what always is the same is that Avogadro's number. Now if you're going from moles to particles, you're multiplying. If you're going from particles to moles, you're dividing. This is the same on both sides there. And the thing that you need to go from moles to moles is that mole ratio. The only thing that you might want to write there with that mole ratio is that that's the coefficient found in a balanced chemical equation, the mole ratio there. So that's the only time that you use that as well. Does anybody have questions on that? Okay, then we're going to go through some examples together. You guys will have a little bit of time to work on a couple of more challenging ones with a partner in a little bit. This first one just says the sample contains 35.6 grams of aluminum oxide. How many molecules of aluminum oxide are in the sample? The reason I have this on there, we haven't really done a simpler problem like this in a while. Now, I just don't want you to freak out when you get the test tomorrow if there's no other stuff on there, right? Because it's not a reaction, right? All it's asking you is how many molecules are present in that many grams. So it's just a simple two-step problem here. So you don't always need a balanced chemical equation is what I'm saying, I guess. So when we're doing this one, you're just going to start out with aluminum oxide. So aluminum oxide is Al2O3. And what we're doing is we're going from 35.6 grams of it eventually into molecules. Okay? So this is where if you have that flow chart written down, or I mean if you have it, if you know it in your head, that's fine too. But that's where this can help you right now, because you can see, okay, I'm going from, I don't have it written up here with grams to moles, moles to particles. So it's 2 steps. Okay? And it even can help you know what you need to use. So we need to use aluminum oxide's molar mass, and we need to divide by that molar mass in order to get the moles. So that's going to go on the bottom. So I'm going to put grams Al2O3 down here. I'm going to put moles Al2O3 on top. Okay. Now I need to figure out how many grams are in that 1 mole. So that's where we're going to use the periodic table. We look, aluminum is 27 times 2, and that's 54. So I write 54 up here. Oxygen is 16 times 3, it's 48. So I have 54 plus 48. Wow, I'm having a brain fart. What is that? 102, 104? I can't think. Huh? Thank you. Simple math. So it's 102 grams. All right. Now, we're at moles here. The last thing we need to do is get from moles to particles. So what I'm going to do is I'm going to write moles, Al2O3 down here. On top, I'm going to write, well, it's molecules actually, molecules, Al2O3. And in 1 mole, the same for every single compound that we ever do. There's 6.022 times 10 to the 23rd molecules. So I know I did it right if the thing that I'm ending with, if the thing that's last on the top right is the unit that it's asking me to find. So it asked me to find molecules of aluminum oxide. I'm at molecules of aluminum oxide here. So it's just a plug and chug from there. So I'm going to take 35.6 times 6.022 times 10 to the 23rd and divide that by 102. The answer is 2.1 times 10 to the 23rd. And that's molecules. Al2O3. Does anybody have questions on that one? So like I said, that's probably the easiest problem that you can do. Now, the next one's going to talk about the decomposition